Graphing exponential functions is the lesson today, and here's the workbooklet. So graph this exponential function, so I'm going to get three main points here. 3 to the negative 1 is 1/3, 3 to the 0 is 1, and 3 to the 1 is 3. So negative 1, 1/3, 0, 1, and 1 comma 3. So it's going to go in upward because the next point would be 2 comma 9. And this is going to continue to decrease, and it's going to get closer and closer to 0, which creates an asymptote. Now I've graphed this, which is the same as that. This means up 1, or in other words, x comma y plus 1. So I'm going to take these three coordinates, negative 1, 1/3, and I'm going to go up 1, so negative 1 comma 1 1/3. I'm going to grab the coordinate 0, 1 and turn it into 0, 2, and the coordinate 1 comma 3 and turn it into 1 comma 4. So negative 1, 1 1/3, 0, 2, and 1 comma 4. And also because of the up 1, the asymptote will now be at y equals 1. And there's my graph. Which graph is this below? Okay, so I know that a half to the x would be, well, 0, 1 is always the point. And if the exponent was 1, it would be a half. So if I did a half to the negative x, that would take that graph and reflect it horizontally. 2 to the x would be an increasing graph. And negative 2 to the x, that's an a negative, so it would take that graph and it would reflect it. So this graph matches a half to the x. So this coordinate is 1 comma half. In other words, 1/2 to the 1 equals 1/2. Which is shown below. Well, that asymptote is down 3, and actually there's only one that matches that because this is moving right and left. That's an up 3 transformation, so the answer is D. What is the x-intercept of this graph? So an x-intercept is where y is 0. So 0 equals 3x minus 1. I'm going to add 1. So now think about what that exponent is. So what 3 to the what is 1? 3 to the 0 is 1. So x equals, whoops, wrong circle. X equals 0. Another way you could have done it was graph it. So we just did 3 to the x, and if we shift it down 1, that's our asymptote. So the original point 0, 1 would be there, and it would kind of go like that. Okay, sketch this graph. So I'm going to do 3 basic points. So a negative, or a quarter to the negative 1 is I flip, so that turns to a 4. Anything to the 0 is 1. A quarter to the 1 is a quarter. So my points are negative 1, 4, 0, 1, 1, 1/4. So So -1, 4, 0, 1, and 1 1/4. I know that it's going to be decreasing because my base is something that's smaller than 1. And the asymptotic behavior is y equals 0. Okay, so now sketching this graph. So I already have the basic 3 points. This is an A. So I'm going to do x comma 2y. So -1 comma 8, 0 comma 2, 1 comma, and if you double a quarter, that should be a half. So -1 comma 8, oh, I can't even get that on here. Almost. 0, 2, 1 comma a half, and then the asymptotic behavior still the same at 0. If you're given this, state the equation of the horizontal asymptote. So this has shifted it up 1. So the equation would be y equals 1. Sketch this graph. Okay, so we've already done the major points here. So remember 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. Now that is a D, so we're going to be doing a y plus 2 and nothing to our x. So -1, 0, and 1 stay put. Now I'm going to have to add 2, so this would be 2 1/3, 3, and 5. 0 comma 3, and 1 comma 5. And then the up 2 will create an asymptote at y equals 2. Okay, sketch this graph. So I'm going to use the base of 2 to create some points. So 2 to the -1 is a half. 2 to the 0 is 1. 2 to the 1 is 2. So there's 3 points. This is an A, and this is a D. So I'm going to be doing x, nothing with it. I'm going to go -1 y plus 2. Okay, please don't mistake 2 as an A, because 2 is to the exponent, and then it's getting multiplied by -1. So base. It's nothing to do with the transformations. That's the base that we used over here. So nothing with our x. Okay, so -1/2, and then plus 2 is 1.5. -1 plus 2 is 1. -2 plus 2 is 0. So the plus 2 has moved an asymptote up 2, and the negative has reflected the shape, so it's kind of like that kind of shape would be normally. So there's the new shape. Number 9, identify how the graph of y equals 3 to the x is transformed. So this would be a B, which reflects coordinates horizontally So that's over the y-axis. So reflects over the y-axis. Determine the x-intercept of this graph. So an x-intercept is where y is 0. So I'm going to move my 1. Now what exponent creates an answer of 0? An exponent, or sorry, an answer of 1, an exponent of 0, right? Because e to the 0 would be 1. Okay, sketch that graph. So I'm going to get some points here. So the base to the -1, that would be 2. 1/2 to the 0 is 1. And 1/2 to the 1 is 1/2. So there's 3 points. Now I have a shift, so that is a C. So x plus 1, because it's going to move right. So these 3 coordinates are going to change. So x is going to go -1 plus 1, which is 0, plus 1, so 1 comma 1, plus 1 is 2. So I'm going to graph those 3 points. Sorry, I got a little messy here. Those are my 3 new points. So 0, 2, 1 comma 1, and 2 comma 1/2. And my asymptote is still on y equals 0 because I did not have any shifts up or down. Okay, state the range, the y-intercept, and the equation of the asymptote of this exponential function. Okay, so I know that the up to is going to be doing that to my graph, and 3 to the x would normally look like this. I'm going to be shifting it right. So it does not change the range. So the range will be 2 with a round bracket because it won't hit that asymptote to infinity. And the equation of the asymptote is y equals 2. So now let's talk about the y-intercept. That is when x is 0. So what happens? Y equals 3 to the 0 minus 1 plus 2. So y equals 3 to the -1 plus 2. So y equals that would turn into 1/3. So the y-intercept is 2 1/3, or 2.333. Okay, and you could have graphed the exact points, but if you have a general idea, you can answer some of those questions. Describe the behavior of this graph as it approaches y equals 4. So this has a shift up 4, and 5 to the x means it will be like that. So what's the behavior? So as you're moving left, your y values are going to be approaching 4 and never touches it. So y approaches 4 but never touches it. You can see how if I keep going, I'm going closer, 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 but never touching it or crossing it. Okay, we're given this graph, sketch that. So we have the coordinates 1, 4. 0, 1, and this would be -1 comma a quarter. Okay, so now what's this equation that we're going to make? This is an A, a C, and a D. So x plus 3, okay, x plus 3, and then 2y plus 1. So 1, 4 is going to turn into 4. You know what, I'm going to just go through all these 3 points with the x values. Add 3 is 4, add 3, add 3. 4 times 2 plus 1 is 9. 1 times 2 is 2 plus 1 is 3. 2 times a quarter is a half, plus 1 is 1 1/2. Okay, so 4 comma 9. And then 3, 3. And 2 comma 1.5. And then the plus 1 has moved the asymptote up 1. So there's the new graph.